Hi everyone, we are going to continue with our notes for this chapter. So we are going to be looking at velocity and momentum calculations. So this video is going to be just about the velocity piece of these calculations. So our essential question that we'll be able to answer at the end of this is, how does a change in velocity affect the momentum? Okay, so this equation is really familiar because it looks just like the speed equation. The only difference is that instead of S for speed, we're going to be using V for velocity. So if you look at this triangle over here, velocity is the speed, which is why the equation is the same, but it also includes the direction of the object's motion. So this is going to require an extra unit on the end of our answer. So the velocity is going to be equal to the distance over time. We're going to abbreviate velocity with a lowercase v, lowercase d for distance, and then lowercase t for time, just like we did in our speed equation. So because velocity includes the direction, there's a couple of things we need to know about velocity. So the first one is that velocity can change even if the speed stays the same. So if we're going, let's say 10 miles per hour north, and then we do a real quick turn and we're still going 10 miles per hour, but now we're going east, our speed hasn't changed. So the speed would be the 10 miles per hour. But our direction has changed. We started out going north and then we went east. So we can see that even if the speed stays the same, the velocity can change. So then if we're calculating kind of the same thing, why do we need two different variables, velocity and speed? So I want you guys to take a second. Why would it be important to know which direction something is moving? So hopefully you came up with ideas like you need to know if something is coming at you or if it's going away from you. If we're looking at maybe traveling somewhere, we need to know which direction to move, and then maybe a speed limit along with that. So it's important to know both parts because they give us different information. So when we calculate these, we're going to do the exact same thing we did with speed. We're going to read the equation to figure out what we're trying to find, rearrange our equation, then we are going to define our variables, plug in what we're going to do in our calculator, and then our final answer with units. So this first problem says, what is the velocity of a bird that flies 2 miles north in 5 hours? So I see the question at the beginning here, what is the velocity? So we're looking for v velocity. So when I go over to my triangle, remember to use the triangle, we are going to cover up what we're trying to find. So velocity is what we're trying to find. And we're left with d over t. So my equation is going to be d divided by t, which means that in order to solve this, I need to know what is my distance and what is my time. So I'm going to go back into my problem and see if I know that. So the bird flies 2 miles north. So I see 2 miles. That tells me it's a distance in 5 hours, and that's a time. So once I have my rearranged equation, I've defined my variables. Now I'm ready to plug it into my equation. So velocity equals my distance, which is 2 miles, over my time, 5 hours. And in math, in science, we always use decimals. So I'm going to take 2 divided by 5 on my calculator, and I get 0.4. So now I need units. Miles is on the top and hours is on the bottom, and I don't have either of those anywhere else to cancel off. So I have to keep both. So I'm going to do miles per hour. And that's a speed, but we're trying to calculate velocity, so we need a direction. So when I go back up to my equation here, it must be spring because the birds are flying north. So I'm going to add an N for north at the top of it. So when you guys are doing your practice, make sure that you include all three parts. So this is the first part. You're rearranging your equation to finding your variables. The second part is what are you going to put in your equation? And then the third part is final answer with units, and make sure you have all the units. So you guys are going to do some practice with that, but I want to again clarify why we have kind of two different things. Let's fill out this t-table that looks at the difference between speed and velocity. So our equation for speed is s equals distance over time. And velocity is also that, v equals d over t. So we can see that the equation is the same. The meaning is a little bit different. So when we know a speed, we just know how fast something is moving. When we know the velocity, we know how fast and what direction something is moving. Okay, and then finally when it changes. If we're just looking at how fast something's moving, it changes when an object speeds up or slows down. Okay, so another way to say that is obviously like when they change speed. Okay. Velocity, because it includes how fast and what direction, it's when an object speeds up, slows down, or turns. So the velocity changes more frequently than the speed. When you guys are doing your practice, make sure that you are including each part of the calculations and that you're showing all of your work and that your final answer has the correct unit.